Welcome back for another SVSU Math and Physics Resource Center tutoring video. My name is Brendon. I'm going to be your tutor for this video, and we are going to go into part 3 of power series. We're going to find the interval and radius of convergence of another power series example. Hope you guys enjoy. Alright, so let's get into this power series example. We're going to go through this and find the radius and interval of convergence of this series, and we're going to do that by using the ratio test. Okay, so just like on the last video, what we're going to do is we're going to start out by defining our a of n term, and then let's write out our a of n plus 1 term. Okay, so if I do this, I'm going to get n plus 1 divided by 2 times n plus 1, and then factorial, and then multiplied by x minus 2 to the n plus 1. Okay, and then we just want to simplify this before we plug it into the limit for our ratio test. So it looks like we'll end up with an n plus 2 on the numerator, and then I'm going to move this piece to the numerator as well, so that's going to be an x minus 2 to the n plus 1. Divided by, and then let's see what we're going to get in the factorial is just going to be a 2n plus 3 factorial. Okay, so now let's go ahead and start the ratio test. So we're going to do the limit as n approaches infinity of the absolute value of a of n plus 1 multiplied by 1 over a of n. So this is going to be the limit as n approaches infinity of a of n plus 1, so that's the term we just simplified. That's going to be n plus 2 multiplied by x minus 2 to the n plus 1 divided by, let's see, this is going to be the 2n plus 3 factorial, and then multiplied by our a of n term. So, sorry, the reciprocal of the a of n term. So in the numerator, we're just going to have a 2n plus 1 factorial, and then in the denominator we're going to have an n plus 1 multiplied by an x minus 2 to the n. Okay, and then so now what we want to do is we want to just simplify as much as we can. So I know I have an x minus 2 to the n that's going to cancel with my power of n in the numerator, and so that we can, using the exponent rule, we can imagine this being an x minus 2 to the first power times x minus 2 to the nth power, and so we're canceling out the one that has the nth power on it. Okay, and then let's look at these factorials. Let's go into a little more, maybe a little more in depth on the factorials. So this 2n factorial, or sorry, the 2n plus 1 factorial is 2n plus 1 multiplied by 2n multiplied by 2n minus 1, and then dot dot dot. And the denominator factorial, so that's the 2n plus 3 factorial, that's 2n plus 3 times 2n plus 2 times 2n plus 1. And if you notice, we're just subtracting, so for factorials, we just subtract 1 on each one. And then, so we'll have a 2n, and then a 2n minus 1, and dot dot dot. Okay, so then it looks like all of these are going to cancel with all of these, and then all of the terms to the right are also going to cancel with each other. And then we're just going to be left with a 2n plus 3 in the denominator and a 2n plus 2 in the denominator. Okay, so let's see what this all simplifies down to. So this is going to be the limit as n approaches infinity of the absolute value of n plus 2 multiplied by x minus 2 divided by, so I have the 2n plus 3, and then the 2n plus 2 left over from the factorial. Then I have an n plus 1 from this piece here. And I think that's it. So now what we can do is we can pull this x minus 2 out of our limit because it's just a constant with respect to n, right? So assuming we have some value of x, this would be just a constant, so we're pulling the constant out of the limit. So this is going to be x minus 2 absolute value. Now let me write that a little better. So x minus 2 absolute value, the limit as n approaches infinity of, and then we're just going to have n plus 2 divided by 2n plus 3, 2n plus 2, and n plus 1. Okay, so we can actually go through and evaluate this limit now. So if I look at my limit, and my numerator, I have a highest power of 1, so n to the power of 1. In the denominator, I have these three pieces being multiplied by each other, and each one of them has an n in it. So then that tells me my power in the denominator is going to be n to the third, or 3. Right? So that tells me when I plug in my infinity, my power in, or my denominator is going to get bigger faster than my numerator because it's raised to a power of 3 instead of to the power of 1. Right? So if my denominator is getting bigger faster than my numerator, then that tells me that this entire limit goes to 0. So 0 multiplied by x minus 2, no matter what the x minus 2 value is going to be equal to 0. And so we wanted to find the values of x that make this convergent. So for the ratio test, we need this to be less than 1 for this series to be convergent. Well, we found out that since this limit is equal to 0, no matter what the x value is, I'm going to have a constant times 0, which is going to be 0, which is always less than 1, right? So then that tells me that this series, this power series, always converges no matter what the x value is. And so for this, our interval of convergence is going to be negative infinity is less than x is less than infinity. And so that tells us so any value of x, we plug it into the series, and we have a convergent series still. Okay? And then so this is our interval of convergence, and then our radius of convergence is just going to be half of the interval, or just infinity. Okay, hope you guys enjoyed the video. Thanks.